So we'll look at the right angle triangle here. We've got a right angle here, which is the one that's the box around it here. As you can see, we've got an angle down here at the bottom, and we've got a different angle we call the blue angle up there. Let's make these lines a bit heavier. And what we've got is three sides of this right triangle. We've got the hypotenuse, which is the one opposite the right angle. And we've got two other sides, the two legs here and here. Now, if we look at one of these angles that's not the right angle, I'm going to look at this angle here, in the corner here, which we'll call the blue angle here. Now, we know the hypotenuse is this one. That's the hypotenuse, because the hypotenuse is always opposite the right angle. There's the right angle, and the hypotenuse is opposite. Well, the other side, there's two other sides here. If you were to look through a little hole here, the side that you see here is going to be the opposite, always the opposite side. And therefore, if you're looking at this through this little hole here again, this one would be the adjacent. Now, the complicating factor is that if we now looked from this angle up here through a little hole here with your eye, then this side here would be the opposite. And this side would be the adjacent. So depending on which angle we choose, whether we choose the blue angle or the red angle, that will decide whether we've got an opposite or adjacent. The hypotenuse will always stay the same. It's always opposite the right angle here. So that means that if we take this angle down here, and we look at the ratio of sides, we end up with what we know is called SOHCAHTOA. And each of these letters means something. So S means sine. So the sine of angle A will equal the opposite over the hypotenuse. So the opposite length divided by the hypotenuse. So that will be the length of this side here divided by that length there. And in questions you'll be given numbers. This one, the C, means cos of angle A will be the adjacent over the hypotenuse. So the adjacent divided by the hypotenuse. And that will be this side here divided by the hypotenuse. And the last one, the T, stands for tan of angle A. That will equal the opposite over the adjacent. And there we have three ratios for angle A. And of course, if we were to go to angle B, up there, then we'd have the same thing, except the opposite side would be this one here, the blue one here, and the adjacent would be this one here. So it changes depending on which angle we've got. So we know about SOHCAHTOA. So we got angle A here. We know that sine of angle A equals opposite over hypotenuse. Of course, because there's three sides, we've only got three ratios so far. So what they do, there's the other three ratios that are the reciprocals. So cosec A would be hypotenuse over the opposite. And these are all reciprocal functions now. So sine and cosine are reciprocal functions, i.e. they are inverses of each other. So cos A equals adjacent divided by hypotenuse. And the reciprocal of cos is what we call the sec, the secant of A, which is going to be hypotenuse divided by adjacent. And the last one, tan of A, is opposite over adjacent. And the reciprocal of tan is what we call the cotangent, or cot A, which is adjacent divided by opposite. And they are the reciprocal functions. So moving on here, let's try and work out some values here. We know that we're going to give this a value of 30 degrees. And we're going to give this x, and we're going to make this 10. So we're given, for this angle here, we're given the opposite side here. This is the opposite side and the hypotenuse. And if we go to SOHCAHTOA, we know that the opposite and the hypotenuse is this one here. So we can say that sine of 30 degrees equals the opposite, x over 10. Now to find x, we bring the 10 up and multiply. So that 10 times sine 30 equals x. Now sine 60 is root 3 over 2. Sine 30 is actually a nice number, it's a half. And 10 times a half is equal to x equals 5.